Okay. Okay, it's 10:30 now p.m. I guess I'll be doing an hour and up to 11:30 and then go to sleep, I guess. So basically this chapter will cover chapter 3 of the Rust programming language, in case you're following from the previous videos. This chapter will be covering more about variables, basic types, functions, control flow. So basic features that most modern programming languages have. And so we've seen in the last okay, let's create a new project, cargo new variables. Okay, so we have this cargo run. I guess we have to. Okay, so we are getting used to the main flow of Rust programming. So on the last video we've seen something a little bit more. We've done some example with guessing game and such, and we talk a little bit about how Rust declares variables. So let's try this code snippet here, and we would try to run this, and probably would throw an error because we're trying to modify a variable which is not mutable. And so let's see what happens. Okay. So as expected, it threw an error, so cannot assign twice to immutable variables. So let's use this keyword here, let mute x equals 5, and then it works. And then if we remove it again, it will throw an error when trying to compile it. So that's basically what this is covering here. How the compile helps. Indeed, the compile errors are very helpful, different than C++, right? Absolute hell. So you receive the error message, okay, because you're trying to assign a second value to immutable. Okay, so compile time errors, it's important, blah 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 blah. The cause of this kind can be difficult to track down after the fact, contain only sometimes. There is guarantee that the state a value won't change. It really won't change, okay. But mutability can be very useful. You can make code more convenient to write. Although variables are immutable by default, you can make them mutable, okay. So we've seen that in chapter 2, in the last video, in the previous video. So that's basically what we've already done here. So we have constants which are different than mutable, and for practical purpose of this previous example, it was like a constant but not quite a constant. So constants are values that are bound to a name and are not allowed to change, but there are few differences between constants and variables. First, you aren't allowed to use mute keyword with constants. Constants aren't just immutable by default. They're always immutable. You declare constants using the const keyword, so pretty much like C, C++, JavaScript, so on. Keyword, and let me check something. Okay, so I guess people haven't seen my tweet already, but never mind. We can carry on like this. So okay. yeah, you declare constants using the const keyword instead of the let keyword, and the type of the value must be annotated. We'll cover types and type annotations in this next section, data types, so don't worry about detail right now. Okay, so type annotation, oh yeah, I guess it's referring to like you can't when you declare a variable like const, you can't let Rust infer its variable type. You must define its variable type. Like here it's unsigned 32 integer, 32 bits integer, right? Constants can be declared in any scope, including global scope, which makes them useful for values that many parts of code need to worry about. The last difference is that constants may be set only to a constant expression, not the result of a value that could be computed at runtime. So yeah, let's try to run this, and I believe it will throw an error because it's not allowed to be defined at runtime. And yeah, now let's declare this a mute, and then let's run. Yeah, it gives us a warning. Okay, constant 3 hours and seconds never used. So what was it again? A constant expression, not the result. Oh, okay, so it accepts a constant expression, but not the result of a value that can only be computed at runtime. So yeah, we can actually set the constant, a constant like this, so it will not complain. So yeah, let's try it out. So basically, we can do this like prints ln, and then 3 hours. So I guess, yeah, we have to include curly brackets here. Yeah, we need quotes, and then, yeah. So we can actually do something like this, an expression, but if we include, let's say, 5 here, or let's make it 3. And then I guess it will not work. Yeah. Attempt to use a non-constant value in a constant. Okay, so it doesn't, when we declare a variable like a constant, it does not allow us to use a non-constant value or a variable for per se in defining a constant. So this will not work. This will not compile. We will throw an error. So yeah, for more information about the zero type, Rust-C explain E435. So let's try that. I haven't tried this feature yet, so let's see what happens. Okay, so this is really nice. It explains the error and can be quite helpful. This feature, I didn't know about this feature in Rust, so yeah, this sounds really awesome. A non-constant value was used in a constant expression, so this is what the tutorial was talking about. And erroneous code examples, so yeah, error, attempt to use a non-constant value on a constant. Constant means a compile time variable, more details can be found. Okay, so here's it links us to the documentation of the book. To fix this error, please replace the value with a constant. And yeah, a non-constant value in a constant. Okay, so we can use a constant value in a constant, like something like const, let's say const x u32, and then we define it like this. So yeah, yeah, so we can do this because now it's a constant, so I have to comment this line here. And convert identifier to uppercase capitalization. Okay, because it's a constant, so by convention you have to use all capital letters. Okay, and oh yeah, so now we have to adapt the whole code to a similar. Okay, I forgot here also. So yeah, and now it's working. So basically here we can use a constant to define another constant like we did here, but if we transform this like x, then it won't work. So yeah, so let's undo this, make it a mutable type, and here we have, I guess, 3. Yeah, then cargo run, and then that's basically what we had before. So back to it. The constant name is 3 hours in seconds, and its value is the results. Okay, Rust naming convention for constants is to use all uppercase. That's what issue we were having with the x variable. With underscores between words. You know, that's kind of a convention you see in C programs and C++ programs, but I guess that can become somewhat annoying depending on your naming convention, because it kind of forces you into a name convention, and that can be bad. Yeah, okay. So all right. Just a second. Okay. Just a little coffee. The compiler is able to evaluate the limited set of operations and compile time, which let us choose to write out this value in a way. Okay. Constants are valid for the entire time a program runs within the scope in which they declare. Okay, so pretty much like C, C++, and so on. This property may make use of multiple parts of my knowable, such as maximum. Naming hardcode values used throughout the program as constants is useful in conveying the meaning of that value to future maintainers of the code. Yeah, so it's kind of the issue I was talking about, like naming convention. So yeah, that's pretty much it. And yeah, I guess people are already sleeping, or I don't know, who knows. Okay, shadowing. As you saw in the guessing game tutorial in chapter 2, you can declare a new variable with the same name as previous variable. Rustation, say, in case you don't know, Rustation is a Rust developer, so yeah, it's kind of becoming a cult at this point, but yeah, that's I'm only joking, but yeah, you have to admit it's a little bit weird, right? So yeah. Okay, Rustations say the first variable is shadowed by the second, which means that the second variable is what the compiler will see when you use the name of the variable. In effect, the second variable overshadows the first, taking any uses of the variable name to itself. Until either itself is shadow or the scope ends. We can shadow a variable by using the same variable's name or repeating the use of that keyword as follows. So it kind of functions as a typecasting, but in the previous example, like chapter 2, when we used to declare the guess from string to integer and so on. But this now feels and looks very weird to me. Like, can we simply, instead of writing like this, write x equals x plus 1? So this don't really make much sense in this example, of course. So yeah, here we have an inner scope, and then Okay, let's check what this. So yeah, here we have 5, and then here 6, and then 12 within this scope, and then within this scope I believe it would still be 6. Yeah. The program first binds x to the value of 5, then it creates a new variable x by repeating let x equals, taking the original value and adding 1, so the value x is then 6. Okay. Then within the inner scope created, okay, the third also shadows x and creates a new variable multiplying the previous value and giving the value 12. When that scope is over, the inner shadowing ends. That's interesting. X returns to being 6, and we run the program, it will output the following. So this is the tricky part here, how shadowing works. So within this scope, the value is changed, but when we return to this scope, the value remains the value which was in that scope. So yeah, that's completely different from everything I've seen in other programming language. I don't recall any feature which remotely resembles this, like in C, C++, or other languages as well. But yeah, whatever. Okay, let's try this out. I will use the same code here. So yeah, I guess this is a bit of a mess. So let me move this right here. And yeah, so let's declare it. So let's say y instead of x, just to not use the same variable. And let's see this thing regarding the scope in action here. Scope and what is called in Rust shadowing. Okay, which sounds very weird to me at this point. A lot of things sound weird, but this one is really weird. Okay, so oh yeah, we have to change this here as well, otherwise it will confuse us later on. So yeah, okay, here's our previous example, and then a y. In the inner scope, indeed, was changed to 12, but then it came back from this scope and it returned to the previous value. So let's just check this thing for sanity. Checking. So here it should be 6, and here it should be 5, right? So that's just checking. Okay, 5, and then it was changed to 6, and then the inner scope 12, and then back to 6. Okay, it makes sense. And I guess we can remove this. And yeah. So yeah, shadowing is different from marking a variable as mute. So yeah. Here, as I didn't have noticed, this variable wasn't marked as mutable. However, we did manage to change this variable by using shadowing. Yeah, that's interesting. So okay, back to here. It's different from making a variable as mutable because we will get to compile time error if we accidentally try to reassign to this variable without using the let keyword. By using let, we can perform a few transformations on a value but have the variable be immutable after those transformations have been completed. I'm wondering what use case such a feature would have, like yeah, let me check Stack Overflow because I'm curious right now. Stack Overflow. use case, or yeah, I don't know, just search Google use case of shadowing in Rust. Okay, I want a practical example. Or we can simply ask ChatGPT, you know, for a practical example of where this can be helpful. So yeah, here we give another example. But unless we can perform a field transformation on the variable, have a variable mode. Okay, so we stopped here. The other difference between mutable and shadowing is that because we're effectively creating a new variable and we use the let keyword again. Okay, we can change the type of the value but reuse the same name. For example, say our program asks a user to show how many space they want between some text. Okay, so we give an example. So let's check ChatGPT about this thing regarding practical use case of shadowing. Can you give a practical example of use case of the concept of shadowing in the Rust programming language? Okay, so I ask GPT, and it says the following. Okay, so this we already know. Practice of reusing a variable name, the same scope, effectively hiding or shadowing the previous value of the variable. Okay, this can be useful in situations where the new variable or the new value of the variable has a different type. The variable has a different type or usage than the previous value. Okay. Yeah, this we already know. I want a more. Can you give a real-world example in software engineering? Okay, imagine you're building a function that takes a user age and returns a string that describes the user's age group. The function could use shadowing to reassign the value of the age variable depending on the age group the user belongs to. Okay, so it has a function here, takes an integer 32-bit, returns a string. I guess here it's basically the same syntax as Python. I didn't get to here, but I'm guessing. So yeah, returns a string. So we have age, if age. Okay, so it's using shadowing to sort of convert. If you think about this in a Python way or C or C++ way of developing, it would be like a typecasting of sorts, or simply converting. Yeah, it's like a typecasting of sorts. And in this example, the function takes in a user's age and assigns a value to the variable age. Then it uses a new else statement. Okay. Functions return the string that describes the user. This example illustrates how shadowing can be used to simplify the code. Oh, That's what I was looking for. Simplify. I want to simplify my code, not complicate my code. I want to make things simpler. That's what I look. That's why I'm running Rust and instead of studying C++ right now. Okay, so that is really nice. Simplifying the code by allowing for the reuse of a variable name and make the code more readable by giving the variable a new semantic meaning. This way the variable age is used for the inputs and the output, which makes the code more expressive and less prone to errors. So you can do something similar in Python, but not quite. Like it doesn't have this concept of shadowing, but yeah, you can, because Python is dynamically typed, it's not statically typed. But here the nice thing is that you have a static type language, a compile language, that you can do this sort of stuff, like makes your code more flexible, I guess. So yeah, that is very, very interesting. So yeah, let's go back to it. Yeah, so here the tutorial. The other difference between mute and shadowing is that because they're effective, okay, and we can change the type of the value, but reuse the same name. For example, say our program asks the user to show how many spaces they want between some text by inputting space characters, and then we want to store that input as a number. Okay, let's try this. And okay, we have a lot of stuff here already. So quotes and then curly brackets and then spaces and cargo run. So here we have 1, 2, 3. Okay, we have 3 spaces. First spaces variable is a string type, and the second spaces variable is a number type. Shadowing thus powers us from having to come up with different names, such as spaces string and space num. Yeah, that's what you would do normally, like C++, right? Instead, we can reuse a simpler space name. However, if we try to use mute for this, as shown here, we get a compile time error. So yeah, let's try this. Let's mute. Warning, variable does not need to be mutable. Okay, it does not need to be, but it was declared as such, so that's interesting. Newer says we're not allowed to mutate a. Okay, so we have to remove this and then oops. Yeah, so now we're gonna get an error. Mismatch types. Expected string found use size. Yeah. This is the same error. Yeah, we're not allowed to mutate the variables type. Now that we explore how variables work, let's look, okay, more data types. Okay, let's change this back to, oops. So this would be the concept of shadowing. And that's, okay, it's basically do something like this, and then yeah, let's separate our code like this, so keep it more organized. And here we have a constants shadowing, and then here we have another topic. Right. So data types. Before I continue, I'm gonna make I'm gonna just make a pause of 1 minute because I need to drink some water. So yeah, just a second. And let's see how we're doing here. We have 2 for watching. Yeah, I don't know at this point. Yeah, we caught people like in vacation and sleeping and so on. I guess there's other lives going on, but yeah, I'll keep this. It probably will be up by tomorrow, and let me check something real quick. Yeah, I've been live for like half an hour, 30 minutes. Let me move this right here. Probably when YouTube finishes processing the video, like it will be like for tomorrow already, and then this video will be available on the Rust tutorial playlist along with the other 2 videos on the Rust programming language, the book. And I guess I will edit this parts out to leave it without interruption. So yeah, it's better to watch it like that way. Oh god, there I was thirsty as hell. Okay, so back to it. Data types. So yeah, every variable in Rust is of a certain data type, which tells Rust what kind of data. Okay, I think this is where I know this. Rust is static type language. You must know the types of all variables at compile time. The compiler can usually infer what type we want to use based on the value and how we use it. In case when many types are possible, such as when we convert a string to a numeric type using parse. I was here. Where is it? Okay. Okay. So yeah. We must add a type annotation like this. If we don't add the EU32 type annotation shown in the preceding code, Rust will display the following error, which means the compiler needs more information to know which type we want to use. Okay, so let's try this out. And now we are on data types. Okay, and simply print this here. Oops. Forgot a semicolon. Okay, let's now remove this type annotation here, and then yeah. Type annotations needed, so it indicates where. Help. Consider giving gas an explicit type. So yeah, the compiler warnings and error messages are really incredible. I have been saying this like since the beginning, but yeah, it's outstanding really. I really like that about Rust. It's one of the things and then this also, it's awesome. So like you don't know what's going on, and it basically tells you detail by detail, gives an example, and yeah, the documentation is really how do you say it? It's really useful, right? It covers all type of scenarios, gives an examples, and so on. So okay, we have an example here. We can comment here. Must includes type annotation. And yes, we can comment this because this will not compile, will throw error. And here yeah, we had this thing with the consoles, but yeah, let's do that for later. Okay, back to it. Yeah. Scalar types. A scalar type represents a single value. Rust has 4 primary scalar types: integers, floating point numbers, booleans, and characters. Yeah, pretty much like C. Its basic types are int, char, float, and also you have double, and when it's actually a long float, right? Doubles and booleans, you don't have a boolean as C, but it's really a one as an assigned integer. We can have values like 0 or 1, but you have booleans in by default in C++. And also, yeah, you know, Python. You may recognize this from another programming language. Yes, so let's jump into how they work in Rust. So integer types. Okay, I won't get in what integer is, so if you're coming from other languages and such, so if you don't know what an integer variable type is, you should look into it. So yeah, this works basically like the standard int library from C, and like we can declare specify the number of bits we want to use for the integer, and we have an unsigned and unsigned of 8, 16 bits, 32, 64, and 128. Yeah. Each variant can be unsigned. Signed referred to it as okay, so we know that. Yeah, because you come from C++ background, and okay, signed numbers are stored in 2 complements representation. Okay. Number of bits that variant uses. Okay, so this is basically, you know, computer science, right? I won't read this, but if you're not familiar, if you don't have a strong background in computer science and like how bits work, you should look into that, but this is not the focus of this tutorial, right? Additionally, the I size and U size types depend on the architecture of the computer your program is running on. So the node of the table arch. 64 bits if you're on 64-bit architecture, and 32 bits if you're okay. In my case, it would be 64-bit, like most modern computers nowadays. You can write integer literals in uniforms on tables. Okay, so here is referring to how we can declare. Oh, this is nice. So instead of writing like 1,000, without a separator. Rust allows us to use a underscore here, so we will have the same. Note the number literals that can be multiple numerical types, although a type suffix like 57 on side 8 bits, I guess. And here allows also for hexadecimal, octal, binary. Yeah, this is really nice. And byte for 8 bits, right? 1 byte equals 8 bits. So how do you know which type of integer to use? If you're unsure, Rust defaults are generally a good place to start. Integer types default to 32 bits. That really will depend on the type of software you're writing, right? Like in C, for example, usually that's not always the case, but an int in C usually is 4 bytes, which corresponds to 32 bit. And C, if you want, of course, you can use standard int. Then you can use the other. You can specify the number of bits, but usually C int is architecture dependent and not design. Is not always equals to 4 bytes. So the primary situation in which you use its size when indexing some sort of collection. Okay, so it has this table here about integer overflow. Yeah, if we try to use more higher, like if we're working with unsigned 8 bits, can hold values between 0 and 255, and if we try to go larger, greater than that, we'll have an integer overflow. So yeah, it's a note on that, so we have to keep it in mind and know which kind of data we're working on, and always use the proper type, right? Rust include checks for integer overflow. That's nice. So let's try that, I guess, see what happens. We declare let's tests u8 equals 156, and then let's print it, and let's see if it warns us that we are about to break something or have an overflow. And yeah, so we got literal out of range for unsigned 8. Note, the literal 256 does not fit into the type unsigned 8 bits whose range is from 0 to 255. So that is really nice. The compiler can detect that we are doing, bad stuff. So let's try it, 255, and it should work. Yeah, and it worked. So let's try a negative value, like what you would say. So yeah, cannot apply an array operator to type unsigned, and then let's switch to, and it works smoothly. So yeah, that's really interesting. Yeah, let's try this. I found this feature very interesting. Like I guess we have 32 bits would suffice here. Let's make it unsigned so we have plenty of space, and then we print. Yeah, so we got 1000 using this thousands separator here, and that's really interesting. So let's see how you're doing. Oh, we have 5 people watching right now, so that's also nice. That's really nice. Okay, here is something about release flag. So when you're compiling release mode, release flag does not include checks for integer overflow that cause panics. Okay, so we have to keep that in mind because we are in debug mode, right? So if we do this in release mode, that could cause some real trouble. Okay, the program won't panic, but the variable will have a value that probably isn't what you're expecting it to have. Yeah, so it will overflows and becomes 1 and so on. To explicitly handle the possibility of overflow, you can use this family of methods provided with the library for primitive numeric types. Okay. Floating points. Rust also has two primitives of floating points. So we have F32. So F32 will correspond usually to floats in C, C++, and F64 bits, which are usually corresponds to double in C. So double is actually a long float. So you know, technicality is right. And yeah, the default type is F64, so it will be a double if you're thinking in terms of C++. Because on modern CPUs is roughly the same speed as F32, but it's capable of more precision. So yeah, double precision. And if you're working with scientific programming like in C, in C++, you usually use a double. You don't rely on floats anymore, so it's pretty much obsolete if you're doing calculations of sort of mathematical, computational physics, that sort of thing. So we use double type. Like even Fortran has support for doubles, with which will be a floating point number of 64 bits. Okay, so it gives an example here, F32. So yeah, let's just print it out. Just to make sure that we are testing everything that we are seeing, and yeah, so let's make it 32 14 15, which is approximation for pi number. So yeah, it works. And let's make it 64 bits, and yeah, it works also. Let's see if we're not getting any warnings. Okay, no warnings. Right. Numerical operations. Okay, numerical operations, addition, subtraction, multiplication, division, and remainder. So pretty much like C, C++, integer division truncates towards 0 to the nearest integer. Okay, so this is pretty much the same as C, C++, so I won't get into that because this is pretty basic. And we have Boolean types. Main way, if expression, character type. So yeah, it's char, just like C and C++. And also we can declare an emoji. So yeah, we put this cat, heart eye cat emoji in my example here because why not? And let's print an emoji. Let's name it emoji. And actually, do we have something more like where is it? Okay, I found what I was looking for. Like yeah, so yeah, that's what I was looking for. Okay, so we got here. Oh yeah, we have to, and then I guess it's a char, so you can have more than one, right? And yeah, it works. Okay, where is it? Note that when specified char literals with single quotes as opposed to string literals which use double quotes. So it's like C, right? So C, C++ has the same convention. Single quote for char and double quotes for strings. Rust char type is 4 bytes in size. It represents because yeah, Unicode scalar array, which means it can represent a lot more than just ASCII. Except the letters. Okay, so char in C is 1 byte, so that's a difference to keep in mind. So yeah, it won't represent emojis. If I'm not mistaken, it's 1 byte. So yeah, let's try something here. If I just use like this, yeah, we still have to use like double quotes and then yeah, double quotes, curly brackets, and then yeah, here we have my statue here, right? And let's see how you're doing Twitter. Okay. Right, back into it. So yeah, we went to chars and compound types. Can group multiple values into one type. Rust has two primitive compound types, tuples and arrays. So tuples we have in Python, and arrays pretty much like every modern language. So here's a tuple, number of values with various types into one compound type. Tuples have a fixed length. Once declared, they cannot grow, shrink in size. So I guess pretty much like Python. We create a tuple by writing a comma separate list of values inside parentheses. Okay, so we must define the types. No, because Python we just assign it and that's it. But yeah, here we have to declare the tuple, the types of each value, and then assign it each position in the tuple as a type, and the types of different values don't have to be the same. Okay. We added an optional type annotation to this example. So yeah, let's try it out and then print. The variable top binds to the entire tuple because a tuple is considered a single compound element. To get the individual values of a tuple, we can use a pattern matching to this structure a tuple. Okay, so we had to do this to like access. So yeah, let's try this out. Tuples. And yeah, here we have to use ABC because I use Y for another example. Unused variable. Okay, so we can annotate the type like this, like I64, let's say F64, F64, F64. Okay, here we have to be an integer as well. Yeah. Here it's giving us a warning because unused variable. If this is intentional, prefix it with underscore. Okay. If you have any questions, you can use the chat to ask me anything. So yeah. So let's try this. Okay, so in Rust, if the variable is not utilized by convention, it recommends us to use underscore here, right? So that's interesting too. And yeah, let me see how long I am already live. Yeah, almost an hour. So yeah, I guess I will be finalizing this up to this part here, and then continue tomorrow on functions. So okay, binds it, and okay, we can also access the tuple member by directly using periods followed by the index of the value we want to access. For example, okay, let's try this, and then x will be like tuple 2, and then so in Python it will index it, gets the value of it like an array, I guess. So it would do something like this, if I'm not mistaken. So yeah, let's print this here. Simply just for the sake of testing. Here and here. Okay, I forgot exclamation point here. X, and then accesses each element of the tuple with their respective indices. Yeah, so the first index is 0, pretty much like Python also use the same convention. And the tuple without any values has a special name, unit. This value and its corresponding type are both written with parentheses and represent empty value or empty return type. Expressions implicitly return the unit value if they don't return any other value. Okay, so now we have arrays, which yeah, declare pretty much like it would do in. So like this is JavaScript syntax, right? That it will work, I believe, pretty much like C++. Like a tuple, every element of array must have the same type. So yeah, this is basically the same for most of our languages. Like arrays in some languages, arrays in Rust have a fixed length. Okay, so this is like different than Python. So it will work more like a, yeah, it's an array. There's a slight difference between arrays and vectors, right? So yeah, write the values. Okay, let's initialize this array here and give it access its that is allocated on the stack rather on the heap. So yeah, probably we get to dynamic memory allocation on part 4, where you want to ensure you always have a fixed number of elements. So the array isn't as flexible as the vector type. So yeah, that was talking about. So there's a difference between array and vector. Like Python, you don't have arrays, right? We actually have lists, which structure similar to vectors in C++, but not quite. So yeah, so we have arrays, lists, and vectors. So a vector is a similar collection type provided by the standard library. It is allowed to grow or shrink in size. So yeah, it will pretty much behave like a list in Python, and also a vector from C++. In C we don't have vector by standard, but you can implement one. What you have by standard is an array, which can, you know, use dynamic memory allocation to reallocate it in size, and then sort of implement a vector data type. So yeah, if you're unsure whether to use an array or vector, chances are you should use a vector. Chapter 8 discusses vectors in more detail. So yeah, I believe it will resemble, if you're a Python developer, it would resemble lists. However, the arrays are more useful when you know the number of elements. You will not need to change. So yeah, it will store it in the stack and not on the heap. And for example, if you're using the names of the month in a program, you would probably use an array rather than a vector, because it will always contain 12 elements. You write an array type in square brackets and with the type of each element, semicolon, and then the number of elements in the array. So you can infer the number of elements, or you can simply omit and declare like this, so it will be an array of strings, right? Like this. And then here, right? So yeah, for the array we have, where is it? Okay, so we have the type and the number of elements. You can also initialize an array to contain the same value for each element by specifying the initial value followed by semicolon, and then the length of the array in square brackets. The array named A will contain 5 elements. Okay, so they will be all equal to 3 like this. So yeah, let's try this out. Array 2. Let me see if to print it is like same convention as we use like in C++. Like, yeah, so it's the same convention. Yeah, it's one here and months. Yeah, so to access a member of the array, we use the same. We use brackets like this, and then the index of the elements of the array we want to access. Okay, so we went through that already. Accessing array elements. Okay, we already inferred that how we do that. So yeah, it's the same thing as Python, C++, C, JavaScript, I believe Java also. So yeah. Okay, invalid array element access. Okay, so get an array index from the user. Okay. Let me get a glass of water, a cup of water real quick, because yeah, I'm very thirsty today. Okay, I think we're almost at the end here of this section 3. Where is it? Okay. So section 3.2 data types. And after that, I will call it a day, and then go to sleep because I'm very tired. and we'll get to functions tomorrow, or yeah, day after tomorrow, I don't know really. But yeah, we're almost at the end, so if you have any questions you can try to use okay, I'm gonna try Mateus here suggestion and see if it works. Okay. So let's try this. Oops. And oops, cargo run. Yeah, it worked. So this is nice. So to display all the contents of an array, we simply use this syntax here, colon and then interrogation mark. And so yeah, thank you Mateus for always being giving good hints for beginners at Rust. Yeah, so this prints all. Let me leave this cup right here before I spill water all over the place. So yeah, this prints all elements of array. And where were we? Yeah, so invalid array element access. So yeah, so it's basically user inputs like we've seen in chapter 2, and then it handles the error of not entering a number. And then probably here it should handle an error in case user tries to access and an invalid index here, which is greater than the size of the array. So yeah, I guess we'll use the same code here. So this would be, yeah, it doesn't do much than that. It doesn't handle that error. The code compiled successfully. Okay. The program will print out the corresponding value at the index in the array. If instead enter a number past the end of the array, such as 10, you see an output like this. So I guess we can try that with let's, oops, here it's actually array 1, and then let's try something like 5. Yeah, index out of bounds. The length is 5, but the index is 5. So if we go to 4 here, then it should work. Yeah, so we got 5, which is this element right here. Runtime error at the point of using invalid value in the index operation. When you attempt to access an element using indexing, Rust will check that the index specified is less than the array length. If the index is greater than or equal to length, Rust will panic. This check has to happen at runtime, especially in this case, because the compiler can't possibly know what value a user will enter when they run the code later. So yeah, I guess here we will have to handle it like an if statement of something like that. This is an example of Rust, yeah, because if they do that in C, we actually can do yeah, our program will crash, right? Would crash. Is an example of Rust memory safety principles in action. In many low-level languages, such as C and C++ probably, this kind of check is not done, and when you provide an incorrect index, invalid memory can be accessed. Rust protects you against this kind of error by immediately exiting instead of allowing the memory access and continuing. Chapter 9 discusses more of Rust error handling and how you can write readable safe code that neither panics nor allows invalid access. Okay, let's try that with C, if I'm not mistaken. So standard IO, because I believe that the compiler will throw some error if we try to access this, but if the user enters an input, if it is invalid, I believe we will have a segmentation fault of sorts. So like array 1 2 3 4 5, and then at sprints, I believe it will crash. So it will be 0 1 2. So let's try accessing an invalid member. Okay, so yeah, let's GCC test 3, and yeah, we're accessing memory that we shouldn't be accessing, and that's really bad. Like, yeah. Yeah, so as you can see in C, you can actually do something like this, and you know, you're accessing memory that you shouldn't be accessing. So Rust prevents you from doing that. And let's see if it gives us any warnings. I will try to compile with warning flag, and still no warnings that we're accessing an array out of bounds. So yeah, it's really bad. So in Rust, if we try to do this cargo run, yeah, here we actually corrected it already. So yeah, so it prevents us from accessing memory that we shouldn't be accessing, and that's very nice, very safe in terms of preventing, you know, preventing your software from getting hacked, right? That's something you really don't know. So yeah, I guess I will be adding here, since I'm an hour and 19 minutes already live, and there's still pretty much ground to cover, like functions and control flow. And by this point I'm pretty tired. So if you have any questions, if you don't have any questions, I'll be adding, but in case you have any questions, that's the time to do it, and I'll wait a bit, like 5 minutes, and then I'll be ending the tutorial. Right, let's check Twitter, and let's take a cup of water. Okay, so we have 5 people watching right now. So if you have everyone, if you have any questions, this is the time. So yeah, any questions regarding everything we went through. So yeah, we went through the basic data types of Rust. We work with constants, and think about shadowing in Rust, which can be very useful. We asked ChatGPT to give a practical example of usage of shadowing in a real-life example using Rust. And then yeah, here we work with constants and then data types. So yeah, basically we have booleans, chars, and float, and int, and signed int, and oh yeah, char in Rust is 4 bytes while in C is 1 byte. So yeah, there's this main difference. So that's why we managed to use an emoji here. And then we work with tuples. Rust has this convention for constants in the capital letters, and from unused variables, Rust gives us a warning, but it lets us use nevertheless. But he recommends that we use a underscore. What else? Yeah, here's how we access value of a tuple. And then finally we went through arrays, how we declare array. Yeah, how we declare an array, like we can specify its data type and a number of elements, or we can omit and let just Rust infers it, how we access them, and then by how we can print all the elements of an array without using a for loop. Like if you use C++, you will have to write a for loop to print each element of the array. So this is really nice syntax here over here, and I really like that. And yeah, that's pretty much it. So on the next video we will be covering functions, how we can declare functions in Rust and work basic control flow here, if else, match, and so on. So we're not getting to that for this video. So if you don't have any questions, I'll be ending this video here, and yeah, I guess I'll be seeing you next time.